To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear grade 11 students. So I think you have studied up to 13th lesson, right? And now I'm going to do the 14th lesson in your grade 11 science syllabus. So this 14th lesson is going to reflect about hydrocarbons and their applications or users, my dear children, right? So within this lesson part, we'll be mainly focusing about what are the things that are called as hydrocarbons, okay? And we'll be categorizing what are the main hydrocarbons under alkanes, alkenes and alkynes. We'll be drawing out different kinds of structures related to the hydrocarbons. And my dear children, we're going to discuss about the polymers within this lesson, different kinds of polymers that we use in our day-to-day life, and also how does the polymers are being created and what are the kinds of monomers or else main molecules that are included in polymers. Okay, so my dear children, first of all, we'll be focusing about the hydrocarbons. So let me give you a certain kind of a brief in here. A hydrocarbon is some kind of a compound which contains hydrogen and carbon. That is why it is referred as hydrocarbon, hydrogen and carbon. Okay, these things are referred as organic compounds. So let me rephrase, organic compounds. So what do you mean by an organic compound? Organic compound is a compound that contains carbon as the main constituent element. If a certain compound contains carbon as the main constituent element, then such a compound is referred as an organic compound. Okay, such compound is referred as an organic compound. A hydrocarbon is especially a component that contains carbon and hydrogen. So my dear children, first of all, we'll be focusing about hydrocarbons within this lesson, right? We'll be focusing about hydrocarbons. So hydrocarbons. So we'll be identifying the types of hydrocarbons. Then my dear children, we'll be discussing how to show that these hydrocarbons contain carbon and hydrogen. And my dear children, after that, we'll be categorizing hydrocarbons into several groups in order to identify their special properties and their users. After identifying hydrocarbons, my dear children, we'll be moving on to their derivatives. So a derivative means here we are replacing hydrogen in a given hydrocarbon in order to create different kinds of molecules, right? So we'll be learning about these derivatives when you go further with the lesson part, my dear children, right? So these are the things that we are going to discuss about hydrocarbons and their derivatives lesson part. Then my dear children, we'll be studying about the polymers, natural polymers, and about the artificial polymers and other types of polymers as well. Okay, and my dear children, finally we are going to discuss the questions in your textbook, and my dear children, we'll be finally discussing about several extra questions related to the lesson. So stay with me till the end of the lesson to get a knowledge about this lesson, hydrocarbons and their derivatives. Right, so let's move on to observe the first and foremost topic, right? The first and foremost main topics that we are going to discuss within this lesson part. So like I said, first of all, we'll be discussing about the hydrocarbons and their categories. Then my dear children, we'll be discussing about the derivatives of ethene. So ethene is a type of hydrocarbon that we use or that we are going to discuss within this lesson part. Then my dear children, will be discussing about the polymers, the types of polymers that we are using in our day-to-day life and other kinds of polymers that we can identify. Okay, right. So these are the main topics that we are going to discuss within the lesson part, hydrocarbon and their derivatives lesson. Okay, this is the 14th lesson in your science syllabus. So my dear children, let's move on to observe the first and foremost topic. Within this topic, we are going to identify what kind of a thing is a hydrocarbon. So you are given here, the figures show some items that we use in our day-to-day life. So here you can observe plastic goods, clothes, food items, tires, agrochemicals, cosmetics and paints. Okay. So there are different kinds of substances over here. All of these substances, my dear children, contains a main item. So that item is carbon. How can you say that these items contain carbon? Very simple, my dear children. You just burn these substances and check whether a black color substance is getting created or not. If so, then we can say that these things contain carbon because that black color substance is charcoal or ash. Right. So, as you can see, when considering the composition of all of the above materials, presence of carbon as a component or element seems to be a common feature. So, like I said, when you consider these things, my dear children, right, most of the materials that is observed within our environment, most of these things contain carbon. Okay. So, observing carbon is a great feature, or else it is a major feature that can be identified within the most of the materials around us. Okay. So, the carbon is also abundant in plants and animals that we find in our environment, and all the materials obtained from those sources. So, you know that we are carbon based organisms. The main constituent element contained within our body is the carbon. Okay, we are carbon based organisms. So, when you take each and every biomolecule which is inside our body, all of these biomolecules are made up with carbon. We studied these things in the grade 10 first lesson about the biomolecules. Carbohydrates, proteins, lipids, nucleic acids, all of these things are mainly carbon based items. Okay, carbon based molecules, my dear children. So, my dear children, we are carbon based organisms. So, all the things that we obtain from plant and animal materials are also considered as carbon based substances. Right. So, carbon is a very famous and a most common element in our environment. Elements combine with one another in different ways to create very large number of compounds. Quite a majority of them are compounds formed by the combination of carbon with other elements. So, when you take carbon, carbon has a special property, my dear children. What is that? You know that when you take the electronic configuration of carbon, you know that carbon is located within the periodic table. We can count hydrogen, helium, lithium, beryllium, boron and carbon. So, carbon is in the 6th place. That means the electronic configuration goes as 2, 4, means carbon can create 4 bonds. Right? Carbon can create 4 bonds. Because of that ability, carbon is found in our nature abundantly. Okay. So, my dear children, this carbon atom is very specific and very unique, right? So, this carbon can create different bonds with combining with different other kinds of materials, right? Then, because of the abundance of carbon contained in compounds and the special chemical characteristics shown by those compounds, carbon chemistry, right? Carbon chemistry. So, you know that there are several organic materials, or else there are several carbon based materials in our environment. Okay. So, therefore, there is a special section related to carbon based chemistry, which is referred as the organic chemistry. So, in here it is given carbon chemistry or else organic chemistry is studied as a separate section under chemistry. So, this lesson is a chemistry lesson, you know that. Okay. So, within this chemistry lesson, my dear children, we will be learning about carbon based substances. Okay. We will be learning about carbon based substances. So this chemistry can also be divided into two main categories as organic chemistry and inorganic chemistry. Within the organic chemistry, my dear children, we'll be specially focusing about carbon-based substances. Okay, it's because of the vast majority of carbon-based compound which is available in our environment. So because of having those materials, carbon chemistry is studied as a separate section in the chemistry when you go further with your grades. Okay, so my dear children, up to now we are discussing within the chemistry part. We are not going to divide organic chemistry and inorganic chemistry, but however when you go further with the grades, you will be studying chemistry under two different categories as organic and inorganic. But now we are studying just the chemistry, mixing both of those areas. Okay, so the specialty here is that because of having several compounds of carbon, organic chemistry is being studied as a separate section. Okay, that's how the chemistry works. Okay, then my dear children, let's head on to see what are the other contents then. The compounds contained in carbon are commonly referred to as organic compounds. So like I said when I'm starting the lesson, the compounds that contain carbon are most commonly referred as organic compounds. Organic compounds. So these organic compounds are the compounds that has the carbon as its main constituent element. Okay, that has carbon as the main constituent element. However, my dear children, there's a small bit of a difference here. Even though materials contain carbon, even though some materials contain carbon, these materials or these compounds are not considered as organic items or organic compounds. So here you are given with such examples. The oxides of carbon, namely carbon dioxide and carbon monoxide, and carbonates and bicarbonates such as sodium carbonate, Na2CO3, and sodium bicarbonate, NaHCO3. Now, sodium carbonate, Na2CO3, and sodium bicarbonate, NaHCO3, these things are called as, right, these CO3 is called as a radical. I think you know about these things. CO3 2 minus, which is the carbonate radical. So when carbonate radical is going to join up with different kinds of other elements like magnesium, sodium, potassium, right, calcium, in that case carbonates are getting created. Okay, this particular radical HCO3 minus is referred as the bicarbonate ion. Okay, bicarbonate radical. So when bicarbonate radical joins with different kinds of elements like magnesium, sodium, potassium, calcium, then bicarbonates are getting created. So these carbonates and bicarbonates both are not considered as organic substances. Other than that, the oxides of carbon, okay, oxides of carbon, which is carbon monoxide, CO, right, and carbon dioxide, CO2. Both of these things are not considered as, right, both of these things are not considered as organic substances. So my dear children, oxides of carbon, carbonates and bicarbonates, these things are not considered as organic substances even though they contain carbon. Okay, here the reason is carbon is not a main constituent element that forms the compound. That is why these things are not considered as organic substances. Okay, so these things, oxides of carbon, then the oxides of carbon, and then bicarbonates and carbonates, those things are not considered as organic materials or organic compounds. Then the next point, organic compound necessarily contain, right, organic compound necessarily contain carbon, and in addition they may contain elements like hydrogen, oxygen, nitrogen and halogen. So what do you mean by a halogen? Halogen is a group 7 element like chlorine. So a group 7 element is called as a halogen. So if a certain compound, right, if a certain compound is organic, then other than carbon, my dear children, it will contain these kinds of elements. Like what? Like hydrogen, oxygen, nitrogen and halogens, okay, or else maybe halogens. So if they contain these kinds of substances with carbon, then my dear children, these things are most commonly referred to as organic substances, okay. So halogen is a group 7 element, remember, like chlorine, right. So other than that, you can observe phosphorus and sulfur too, okay. So they might contain elements like hydrogen, oxygen, nitrogen, halogens, phosphorus and sulfur, okay. So these organic substances contain these elements other than carbon, okay, other than carbon. Sometimes these things contain these kinds of elements, right. For the convenience of study, organic compounds are classified in various ways. One method is classifying on the basis of the component elements in the organic compound. On this basis, the simplest group of organic compounds are hydrocarbons, which contain carbon and hydrogen only. So like I said, my dear children, when I was starting the lesson part, can you remember? Hydrocarbons are the ones or the compounds that contain only carbon and hydrogen. So hydrocarbons mainly contains carbon and hydrogen as their main constituent element, my dear children. However, there are different ways of dividing these organic materials, right? So according to this lesson, my dear children, we'll be mainly focusing about the hydrocarbons. Okay, we'll be mainly focusing about the hydrocarbons. So there are other types of organic materials as well, but however within this lesson part we'll be only focusing about the hydrocarbons, which contains only carbon and hydrogen. So this hydrocarbon is a type of an organic substance. This is the simplest group of organic substance, okay. This is the simplest group of organic substance, hydrocarbons, right. Then so you are given with an assignment then. Let's see. List several types of fuels that are used in our day-to-day life. Investigate into the chemical composition, the elements they contain of those fuels. So this is an assignment. So you should find out the things contained within the assignment. So this is your responsibility to find out and complete the assignment, my dear children. However, in order to guide you guys, I will give you 3 components, 3 main petroleum based fuels and their composition. Okay, composition means the elemental composition, right? So let's take petrol. You know that petrol is a common fuel that we used in our vehicles. To operate engines in our vehicles, we use petrol. And diesel, kerosene oil, all of these things are petroleum based fuel, right? So we'll write down different kinds of fuels. So petrol, elemental composition, it contains carbon and hydrogen. Diesel, once again it contains carbon and hydrogen. Then kerosene, in kerosene also, as the main constituent elements, you can observe carbon and hydrogen. So all of these substances, all of these fuels, they contain carbon and hydrogen as the main constituent elements. If you take firewood, in firewood, my dear children, we can observe several elements: carbon, hydrogen, oxygen, sulfur, nitrogen, and so on. Okay. However, my dear children, within these, you can observe only carbon and hydrogen as the main elemental composition. Okay. So I have written down 3 of the examples, 3 of fuels. So you try to find out other types of fuels that we use in our day-to-day life and try to find out their chemical composition, my dear children. Okay, this is very important because you are the one who is very important, or you are the one who is responsible in doing these assignments. I'm just giving out a guide only. Okay, right then. So I hope that you guys will find out the other fuel types, the day-to-day using fuel types and their elemental composition, right then. So let's move on to see the next content. So now you are given with a table. Okay, so here it is given. Compare the list you prepared with the following table. Now I have given you guys with 3 different fuel types. So petrol, diesel and kerosene. Let's compare those things with here. So kerosene, as you can see here, kerosene contains carbon and hydrogen. Diesel, it contains carbon and hydrogen. Petrol, it contains carbon and hydrogen. Other than that, wax contains carbon and hydrogen as the main elements. Then my dear children, methane gas, which is also considered as the main component in biogas. So methane, biogas contains carbon and hydrogen. I think you guys know methane is going by the chemical formula as CH4. Methane is CH4, right? So LP gas, once again, LP gas also contains carbon and hydrogen as the main elements. Then firewood. So can you remember I told you about the firewood? So it contains carbon, hydrogen, oxygen and nitrogen. Okay, as the main elements. Carbon, hydrogen, oxygen and nitrogen. So by looking at this table, you can observe that most of the fuel that we use in our day-to-day life are carbon and hydrogen based ones. That means hydrocarbons. So here it is given here. It is seen that every fuel in the above table contain carbon and hydrogen. So let us do the following activity to examine whether wax contains carbon and hydrogen. So now it's time to do a certain experiment. Within this experiment, my dear children, we are going to find out whether candle wax contains carbon and hydrogen. Okay, whether the candle wax is going to contain carbon and hydrogen. So this is the experiment now we are going to do. Now let's see the experiment then. So to do this activity, you will be needing these materials, my dear children. So what are the materials that you need? So you will be needing, first of all, a candle. So it's quite obvious. You'll be needing a candle in order to get the candle smoke or the product created during the burning of candle wax. Okay. Then we'll be needing lime water. Here we are going to burn, right? Here we are going to burn the candle wax and we're going to bubble this burnt smoke through the lime water. If that smoke contains carbon dioxide, then my dear children, what will happen? The colorless lime water will definitely turn into milky white. Why is that? Because that's how we observe the presence of carbon dioxide, right? You know that calcium hydroxide is the chemical found in lime water. So upon bubbling carbon dioxide gas through it, calcium hydroxide turns to milky white, creating calcium carbonate, right? So my dear children, we can give the presence of carbon dioxide if the color change is going to happen. Okay, so when you take carbon dioxide, in order to create carbon dioxide, through the combustion process, definitely there should be carbon present in it. Okay, otherwise we won't be able to observe carbon dioxide, no. In order to create carbon dioxide, definitely there should be carbon, okay, carbon as the main element. Carbon is the one which is going to react and interact with oxygen gas in creating carbon dioxide gas. So therefore, if the lime water going to turn into milky white solution, then we can say that carbon dioxide is there. Then if carbon dioxide is there, definitely carbon is present within the candle wax. Okay, right. So we use lime water to investigate whether carbon dioxide is emitting or not. Then my dear children, will be needing a boiling tube, right, a boiling tube, then a U-tube, U-shaped tube, okay. Boiling tube. So then we'll be needing a funnel. This is anhydrous. Actually, it should be in white color, my dear children, or else you can use the blue color one, but you have to heat these things. Okay. So by just looking at the blue color, you can clearly identify that this is copper sulfate. So we'll be needing anhydrous. Okay. Anhydrous. That means white color. Right. White color copper sulfate. Right. Anhydrous, that means white color copper sulfate. Right. Anhydrous means it doesn't contain water. So what is the purpose of using anhydrous copper sulfate? We use anhydrous copper sulfate in order to observe the presence of water vapor. With water vapor, anhydrous copper sulfate is going to provide a blue color, right? The usual color of anhydrous copper sulfate is white color. You can use hydrous copper sulfate like in here within the figure, and you can heat it, okay? Upon heating, these things are getting converted into white color substance, which is referred as the anhydrous copper sulfate, right? This blue color one are referred as hydrous copper sulfate. Blue color ones are hydrous copper sulfate, means that hydrous copper sulfate is mixed up with water, okay? So we have to remove the water. To remove water, we can heat it. Upon heating, it is getting converted into white color copper sulfate, which is anhydrous copper sulfate, okay? So we'll be needing that anhydrous copper sulfate to carry out our experiment, okay? So here we are going to observe whether water is present within the candle wax smoke or not. If water is present, then definitely the anhydrous copper sulfate will change the color from white to blue, right then. Then we'll be needing a delivery tube in order to deliver the gas, right? In order to deliver the gas. Right, so we'll be needing a candle, lime water solution, boiling tube, U-tube, funnel, anhydrous copper sulfate, that means white color copper sulfate, and a delivery tube to deliver the gas. So these are the materials that we need, my dear children. And there is another one, we'll be needing an aspirator, right? So we use this aspirator in order to operate the system, in order to absorb the smoke from the candle wax towards our system, okay? So there is an aspirator is very important for this activity. Right, now let's head on to see the method. So method is quite simple, my dear children. What you have to do is, you have to place the materials according to the given diagram. Then what you have to do, then you have to connect this boiling tube, okay, to an aspirator, Then what will happen? Then you have to operate the aspirator. When the aspirator is going to operate, the candle smoke will go towards the U-tube, and within the U-tube you can observe the copper sulfate. It's better to use a beaker, water beaker like this, so that the smoke is cooled down quickly and the vapor is being absorbed very well to the copper sulfate over here. Then my dear children, the smoke which is coming from here, right, will eventually travel through this delivery tube and will come towards the lime water over here. So when bubbling this thing into the lime water solution, if there is carbon dioxide gas, then the lime water will turn into milky white. If there is water vapor in the smoke, then the copper sulfate will turn into blue color. Okay, so this is our activity, my dear children, right? Now let's write down the method of doing this thing. Very simple. What you have to do? Arrange the setup as per to the diagram. As per to the diagram, right? Arrange the setup as per to the diagram. Then what you have to do? Turn on the aspirator and observe the changes. Right. So what do you have to do? Very simple, my dear children. First of all, you have to arrange the setup as per to the diagram which is given here, right? Then my dear children, you have to turn on the aspirator and you need to observe the changes, right? So this is how to do the activity. Very simple, right? So now let's head on to the laboratory, my dear children. We'll do this activity and we'll observe what is going to happen to the anhydrous copper sulfate and to the lime water solution when I'm going to turn on the aspirator. Okay, right. So let's head on to the laboratory and we'll do the activity, and once again we'll come back to the classroom to write down our observations and conclusions. Now in this activity we'll be studying about the products created during a combustion of a fuel, right? Especially here we are discussing about during a combustion of a candle like this. Okay, what are the products which are getting created? So I have prepared a certain apparatus here with several materials. So one by one I'll let you know what are these things. So here first of all we'll be needing a stand. So this stand is being used to fix all the other materials firmly, like in this setup. Okay, so then we'll be needing a funnel, right? That funnel is being used to direct the smoke which is getting emitted from the candle towards the system which is in here. Okay, so the delivery tube which allows to flow gas or the product which is coming from the candle. Then here you can observe a U-shaped tube. This is a U-shaped tube. It's been like drawn into a shape of a U, right? And the smoke which is coming from the delivery tube going through this arm of the U-tube and traveling to the other arm as per to the apparatus. Then at the two ends I have stopper it, right? I have applied several stoppers at the two ends so that the gas which is coming from here is going through there to the next arm, and it is getting exit from the nozzle in here towards the other vessel which is on here. Okay, so inside the U tube here you can observe there is certain chemical. In here there is one certain chemical, right? This chemical is copper sulfate. This chemical is copper sulfate. Especially this copper sulfate, this type of copper sulfate is called as anhydrous copper sulfate. Anhydrous copper sulfate. Usually if you take copper sulfate, it will be like this. Copper sulfate, usually it will be like this. See, this is usual copper sulfate. It's in blue color. See, it's in blue color, right? Usual copper sulfate. This is hydrous. Hydrous means it contains or it absorbs water. So this is hydrous copper sulfate. So anhydrous copper sulfate means after heating these copper sulfate, you can take some amount of blue color copper sulfate and you can heat it. So when you heat copper sulfate, the water vapor which is absorbed to the copper sulfate crystals will get evaporated, and the copper sulfate crystals will turn into a white color like this, which is in the U tube. Okay, so this is anhydrous copper sulfate, okay, which I have prepared by heating up hydrous copper sulfate. Okay, so when there is water vapor, when water vapor is getting absorbed with copper sulfate, the color of this copper sulfate is getting into once again blue color, the original color of copper sulfate. Okay, but in order to do that, it should be come in contact with water vapor, and those water vapor should absorb into the copper sulfate crystals. Right then, so then finally the smoke coming from the candle goes through this delivery tube to the DU tube. Then after that, from the second delivery tube towards this vessel. So this vessel contains lime water solution. You can observe it is colorless, right? The lime water solution, it is colorless, do not contain any kind of a color, right? So it's a colorless lime water solution. So the smoke which is coming out from the candle passes through the candle towards the delivery tube, towards the U tube, goes through the copper sulfate crystals, anhydrous copper sulfate crystals, comes with the other arm and goes through the delivery tube here and comes down and travel through, or it's getting bubbled through the lime water solution, right? That's how these apparatus work. But there is a certain thing, we have to connect this thing to an aspirator like this. So I have to, like, you know, we have to suck the air particles out of this system so that the smoke will come directly towards this delivery tube, towards the U tube. Otherwise, if the flame of the candle is going here and there, we can't get a direct observation clearly. So therefore, I have connected this system to an aspirator, right? So when the aspirator is working, the gas inside this system is getting sucked out from the system. So therefore, the flame or the products created in the candle is going to emit only towards the U tube and the other system. So it's important to connect this aspirator, otherwise the flame will go here and there and the products which are getting created will not flow towards these materials. So getting observation would be quite difficult. So therefore, aspirator is providing a time, like enough time to get a good observation from the system or from the experiment. So we'll conduct the experiment and we'll see what are our observations within this setup. Right. So I'll ignite the candle first. Then we'll see what's going to happen. So first of all, I'll use the candle and fix it to the wall like this. Right then, so I have prepared the system right now. So we'll operate the aspirator and keep the candle flame somewhat steadily, so that the smoke is coming out from here, so that the smoke which is coming out from the candle is going towards the system to my right hand side. Okay, right, so we'll operate the aspirator then. Right, so here you can see that the aspirator is working now. So the candle flame or the product which is getting created is coming towards the anhydrous copper sulfate crystals. You can see it. So we have to give it somewhat time, right, so that the products which are getting created during the combustion of candle to come in contact with the chemicals. So here you can observe now gradually the color of lime water solution is getting converted into a milky white color. Can you see? Now when I was conducting the experiment, so when initially this chemical was in the system, the color was like the color of water. Now it's been turned into a milky white color. Here you can observe it. See? And here also we can see that gradually the copper sulfate crystals are also getting converted into light blue color. See? Gradually it's getting converted into light blue color. So we'll give out somewhat time and let's observe. Right, my dear children. Now here you can observe our observations very clearly now. So I have let it for some time and now we can observe pretty much good or pretty much clearer observations. So here you can see copper sulfate solution. So I'll stop this aspirator, right? So I'll stop it now. Okay. So now let's see. First of all, I'll put off the flame in the candle, right? So now gently I am going to remove this setup to show the color of copper sulfate. Right. Okay then. So here you can observe the color of copper sulfate in here right now. See? The color of copper sulfate solution, it has converted into a blue color. Right? We can observe it. It has converted into a blue color. You can see it very clearly. It's been converted into blue color. Means like this copper sulfate, I'll take the actual copper sulfate. So like this, it's been converted into blue color. So original color of the copper sulfate was white color. So when white color copper sulfate, white color copper sulfate means anhydrous copper sulfate. White color means anhydrous. There is no water. So when white color anhydrous copper sulfate come in contact with water vapor or water, it's getting converted into blue color like this. So this is called as hydrous copper sulfate. So due to that gas which is coming out from the candle containing water vapor, this copper sulfate has got changed into blue color once again, right? So we can conclude from this experiment, from this observation, we can conclude that during the burning of candle wax, water vapor is getting emitted. That's why the anhydrous copper sulfate has got into a different color, which is the blue color. Now I'm going to keep it. So I'm going to ask you a simple question. Why do we need to keep a water trough like this? So you saw that I kept the water trough like this and dipped it inside the water trough, and I have fixed it to the two delivery tubes by keeping copper sulfate within the water like this. So what's the reason of dipping this U-tube inside the water trough? It's because the vapor which is coming out from the system is getting cooled down due to the water which is contained in the trough, right? It's getting condensed. Water vapor which is coming out from the delivery tube is getting condensed due to less amount of temperature within the water trough. So to cool the vapor or to cool the products which are coming out from the candle, we can use this water trough, right? Okay. So now let's come on to the other vessel where we use the colorless lime water, right? So here you can observe that the colorless lime water has got also a milky color, a milky white color. This is because of carbon dioxide. From grade 6 onwards, you are going to study that. You are being studied from grade 6 onwards. The lime water, colorless lime water, can turn into milky white solution like this with the presence of carbon dioxide gas. So here also you can observe the colorless lime water has got changed into milky white color. That's because of having carbon dioxide. That's because of having carbon dioxide gas. So where did we receive carbon dioxide to the system? We received carbon dioxide to the system by the burning of candle wax. So here, by using this observation where the color of lime water change, so here this observation can be used to identify the presence of carbon dioxide gas during the burning of candle wax. So this activity finally concludes. During the burning of fuel or else during the burning of candle wax, the main products which are getting created are number 1, water vapor, and number 2, carbon dioxide gas. So let's head on to the classroom and we'll write down our observations and conclusions from the activity. Right, my dear children. So we carried out the experiment and you could clearly get the observations over there. What are the 2 observations? The anhydrous copper sulfate turns to blue color. First observation. Number 2, the colorless solution, the colorless lime water solution turned to milky white. What is the reason for it? The reason is the carbon dioxide, the presence of carbon dioxide gas within the candle wax, right? Within the candle wax smoke, the presence of carbon dioxide gas. So because of having carbon dioxide gas, my dear children, the lime water solution got turned into milky white solution from the colorless solution. So over there the calcium hydroxide turns into calcium carbonate. That's why we can observe the milky white nature. Okay, then over there where the U-tube, right, the anhydrous copper sulfate contained within the U-tube, it turned to blue color with the presence of water vapor in the smoke emitted by the candle wax. Okay, so by doing these two, we can clearly say that these two substances, right, are found in candle wax smoke. What are the two substances? Carbon dioxide gas and water vapor. So how does the carbon dioxide gas and water vapor came to the smoke or came to the candle wax smoke? Those substances came to the candle wax smoke because of having carbon and hydrogen, my dear children. So this experiment confirms the presence of carbon and hydrogen. Because of burning carbon with oxygen, carbon dioxide was created, and because of burning hydrogen with oxygen gas, water vapor was created. Okay, so my dear children, with this experiment, we can come into a conclusion that candle wax vapor or candle wax smoke contains carbon and hydrogen as the main constituent elements. So we can write down our observations and conclusions. Number 1, colorless lime water turns to milky white. Then the second observation, anhydrous copper sulfate CuSO4 turns to blue color from white. So the conclusion, number 1, lime water turns to milky white because of CO2 gas. So therefore, carbon is present. Therefore, carbon is present in wax smoke. Okay. Next one, number 2. So second one, my dear children, anhydrous copper sulfate turns to blue color because of having water vapor, right? So anhydrous copper sulfate turns to blue due to absorbing H2O. So therefore, hydrogen, right? Therefore, hydrogen is present in wax smoke. So my dear children, by doing this simple experiment, we can come into a conclusion that the candle wax smoke contains carbon dioxide gas, which is got emitted because of carbon is present within the wax smoke. And my dear children, we can come into a conclusion that upon turning copper sulfate into blue color, right, There is water vapor for sure. And how does the water vapor came to the candle wax smoke? It's because of having hydrogen, right? It's because of having hydrogen within the candle wax. Okay, so when candle wax is going to burn, carbon is going to produce carbon dioxide, hydrogen is going to produce water vapor by reacting with the oxygen gas. You know that each and every combustion reaction is going to react with oxygen gas. So therefore, carbon is reacting with oxygen to create carbon dioxide gas. Hydrogen is going to react with oxygen gas to create water vapor. So this is how we can come into a conclusion that the candle wax smoke or candle wax vapor contains carbon and hydrogen. Okay, right then. So this activity, this experiment confirms the presence of carbon and hydrogen as the main constituent elements within the candle wax, right? Okay then. So let's head on to see the next content. So it will be seen that the anhydrous copper sulfate contained in the U-tube turns from white to blue. This change in color was brought about by the water produced during the burning of the candle. So like I said, okay, water is created because of the hydrogen, right? Because of the hydrogen. So my dear children, the next one, hydrogen required to produce that water was supplied by the candle wax. This verifies the presence of hydrogen in wax. So like I said, water vapor was produced because of the burning process of hydrogen. So therefore, we can say that wax contain hydrogen. Then the next one, it can be observed that lime water contained in the test tube on the right hand side turns milky. Therefore, carbon dioxide gas has been produced during the burning of candle. The source of carbon in that carbon dioxide is wax. So, how does the carbon dioxide is getting produced? Because of the carbon contained within the wax. That is why carbon dioxide is getting produced. How does the water vapor is getting produced? Because of the presence of hydrogen within the candle wax. So my dear children, finally we can say that this confirms the presence of carbon and hydrogen in the candle wax. Okay, so candle wax contains carbon and hydrogen. This is the final conclusion that we can come from this activity. Right then. So hydrocarbons. Right now we have proved that usually candle wax contain carbon and hydrogen as their main constituent elements. Now we are going to discuss about the hydrocarbons. Let's see. All the countries in the world meets their energy requirements by using petroleum fuels produced by the distillation of crude oil. So within the third lesson, my dear children, we discussed about the how to separate petroleum fuels by using the distillation method. Over there we use the fractional distillation by using the factoring column, right? So fraction over there we use the we used up the fractionating column, right? We used the fractionating column. Then we developed or we produced different kinds of, right? By using the fractionating column, we produce different kinds of petroleum fuels, okay? Like petrol, diesel, then tar and so on. So, each and every petroleum fuel contains carbon and hydrogen. So, each and every country in the world use this petroleum fuel, right? Use this petroleum fuel to operate their machines and vehicles. All compounds in those fuels are hydrocarbons. Based on the structure, hydrocarbons are classified as alkanes, alkenes and alkynes. So like I said, my dear children, all the fuel contained in petroleum fuel, right? All the types of fuel which are extracted by petroleum fuels are considered as hydrocarbons because those things contain carbon and hydrogen as the main constituents. So these hydrocarbons, fuels that contain or else substances that contain carbon and hydrogen, can be divided into three main categories according to their structure as alkane, alkene and alkynes. Okay. Now we are about to discuss these three categories, my dear children. Okay. So let's head on to see what are these types of hydrocarbons. Number one given, alkanes. Alkanes. Have you heard that biogas produced using the waste disposed from poultry farms is used as a fuel? I think you have, right? So you know that biogas that we are going to produce from poultry, not only from poultry farm but also from different other sources, like we can use human and animal waste materials, and when we are decomposing these things, you know that we can produce methane gas as the main constituent of biogas. Okay, so these gases, right, these biogases, my dear children, are considered as hydrocarbons. The main component contained within the biogas is the methane, right? It's the methane. So the main component of it, which is important as a fuel, is methane gas. This gas is also present in the marsh gas produced when organic matter decays in marshes. So you know that in marshy lands, when you go near a marshy land, right, you know that some kind of a terrible smell is coming out. A terrible odor is giving out from the marshy lands. It's mainly because of the methane gas trapped within the marshy lands. So marshy lands contain different kinds of organisms like algae, then different kinds of animals and plants as well. So when these things are getting decayed down, okay, within the marshy lands, the main component gas which is getting emitted over there is methane. That's why that terrible odor is going to come out. Methane has a terrible odor. However, it's a good fuel. So we can burn this thing. I think you have heard about that sometimes some garbage trucks and garbage bins, heavy garbage mountains, sometimes they are going to explode. Beyond these garbage mountains are going to explode within itself. It's mainly because of the methane gas which is trapped inside it. Okay, methane is a highly combustible gas, my dear children. So upon having a very small spark, if there is plenty of oxygen gas in the environment, definitely methane is going to explode or else it is going to burn, right? So because of that, methane is considered as a wonderful fuel, right? So the main fuel or the main component fuel contained within biogas is methane. Methane is a type of hydrocarbon, the simplest hydrocarbon that we can observe. So this is the simplest hydrocarbon and has the formula, you are given with a blank. So the formula for methane is, my dear children, CH4. When we are studying about that table regarding the fuels, I have given you the formula for methane. So CH4 is the formula, right, for the methane, right? For the methane, CH4 is the formula, methane gas, main constituent in biogas. Then you are given with another topic here, the structure of methane. However, it is not given, so we have to draw out the structure. So you know that CH4, in CH4, this is the chemical formula for methane. So CH4 means, my dear children, carbon contains 4 hydrogen atoms like this. You know that carbon can create 4 bonds. So therefore, carbon is going to create 4 different bonds with 4 different hydrogen atoms like this. So this is the structure of, right, this is the structure of methane, the Lewis structure of methane. Each hydrogen element or each hydrogen atom is going to bond with carbon with a single bond. okay, with a single bond. So here you can observe the nature or the structure of methane molecule like this. So methane is the simplest hydrocarbon or else the simplest alkane that we can observe in the environment. This is the simplest alkane or the simplest hydrocarbon. Observe the structure. All of these things contain only single bonds and the chemical formula is given as CH4. Right then. During the mining of mineral oils, the gas ethane comes out from oil wells. Ethane is also a hydrocarbon. Its formula is C2H6. The structure corresponding to this formula is as follows. So, when we are mining, right, when we are mining mineral oil, my dear children, right, the gas called ethane comes out from the oil. A special kind of a gas which is called as ethane, okay. So, ethane is also a type of a hydrocarbon, means it is a fuel, right. So, the formula for ethane is given as C2H6, C2H6. So, the structure corresponding to this element, right, corresponding to this compound can be given as follows. So, the structure of ethane. Now, we are going to complete the structure of ethane. There are two carbon molecules. So, 1 and 2. Two carbon molecules. And there are 6 hydrogen atoms. So, 1, 2, 3. 1, 2, 3. Hydrogen, 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 hydrogen. And now, my dear children, this is the structure for ethane. Structure for ethane. Once again, there are elements carbon and hydrogen. All the carbon and hydrogen elements are bonded with a single bond, right? All things are having single bonds. Single covalent bond can be observed within each and every element, okay? So, this is the structure of ethane, goes by the formula C2H6. Now, by looking at these things, you can identify two distinct properties of alkanes, my dear children. What is that? Within an alkane, all the bonds are single bonds. That means between carbon-carbon atoms, you can observe only single bonds. Okay, and the other thing is that when you check the formula CH4, which is for methane, always the hydrogen count is 2 greater than the twice. Hydrogen count is 2 more than the twice or 2 greater than the twice. Means you know that carbon, there is only one carbon, no, 1 times 2, that's the twice, no, you add another 2 greater than the twice. So 1 times 2 is 2, 2 plus 2 is equal to 4. See, 4 hydrogen is there. C2H6. In C2H6, the number of carbon atoms is equal to 2. So you multiply 2 by 2 twice. Add another 2. Add another 2. 2 times 2 plus 2. 2 times 2 is 4. 4 plus 2 is equal to 6. See, 6 can be observed. So the two different features can be observed when we are studying about these structures. Number 1, always each and every element is having a single bond in here. Each and every element is having a single bond in here. Second main one, always the hydrogen count is 2 more than the twice or 2 greater than the twice. Okay. Hydrogen count contained within the molecule is 2 more than the twice as the carbon atoms, right? Okay then. So I'm going to erase this thing. Let's head on to see the other contents. Consider the methane and ethane molecules described above. Bonds between carbon atoms and hydrogen atoms only are present in the methane molecule, right? So the bond between atoms of hydrogen and carbon, my dear children, this contains only present in the methane molecule or methane molecule, right? So, but in the ethane molecule, there are bonds between carbon and carbon atoms. So, when you are observing methane or else methane molecule, there's only carbon and hydrogen bonds. However, when you are observing ethane molecule, there are bonds between carbon and as well as carbon atoms and as well as carbon hydrogen atoms. Okay. The hydrocarbons which have only single bonds between carbon atoms are referred to as alkanes. So my dear children, if a certain hydrocarbon contains only single bonds between carbon atoms, then those kinds of elements or those kinds of not elements, those kinds of compounds, right? Those kinds of compounds are referred to as alkanes. Okay, those are the ones which goes by the name alkanes. Alkanes contain only single bonds between carbon atoms, only single bonds between carbon atoms. If they contain only single bonds between carbon atoms, right, then those things are contained as alkanes. Okay, then those things are named as alkanes, right? Alkanes. Alkanes, single bond. Ane, single bonds. Remember, right? So, alkanes are a series of compounds. This series has several common characteristics. One of those is that all compounds in that series can be represented by a common formula. So, the next property. Like I said, my dear children, alkanes can be represented by using a common formula, right? So that common formula is given in here. The common formula of the alkane set is CnH2n plus 2. In this, N is the number of carbon atoms in a molecule of the compound. According to the above formula, the formula of the simplest alkane, methane, can be obtained as follows. So, methane, you know that within methane there is only one, right? Within methane there is only one carbon atom. So, carbon 1. So, let's find out the number of hydrogen atoms according to that formula over there. So, hydrogen is equal to 1 into 2 plus 2. Always 2 greater than twice the number of carbon atoms. So, to find out the number of hydrogen, you multiply the number of carbon atoms by 2 and again add 2. So, this is equal to C, you don't write 1. 1 times 2 is 2, 2 plus 2 is equal to 4. So, CH4. CH4. So, the formula of the simplest alkane, which is methane, right, can be obtained like this. You multiply the number of carbon atoms by 2 and add another 2 to get the total count of hydrogen atoms. Remember, all of these elements are bonded with a single bond. That is why those things are called as alkanes. Right, my dear children? So, this is the definition and the properties identified in alkanes, my dear children. So, in simple, alkanes are the substances that contain carbon and hydrogen only. Especially, these hydrocarbons contain single bonds between carbon atoms. Only single bonds. And the other specialty here is that the number of hydrogen atoms contained within an alkane is equal to 2 greater than or 2 more than twice the number of carbon atoms. Okay, 2 more than the twice the number of carbon atoms is the number of hydrogen atoms contained within a structure or within a molecule of alkane. So according to the number of carbon atoms, you can calculate the number of hydrogen atoms. By that way, my dear children, you can get the total count or the total the entire structural formula of the given alkane. Okay, so these are the two main properties that we identified with this lesson or with this chapter regarding the alkanes, right? So I hope that you got the idea about alkanes very well. So my dear children, we have discussed within this chapter several things regarding the hydrocarbons. We studied that hydrocarbons are the ones which contain carbon and hydrogen only. So even we proved that carbon and hydrogen are present within the candle wax by doing a certain experiment. So my dear children, within next chapter, we'll discuss further things related to the lesson part, right? Especially now within the next chapter, we'll be drawing several structures related to the alkanes and alkenes. Okay, alkane, we identified alkanes now. So within the next chapter, we'll be identifying alkenes as well. And we'll be drawing out several structures related to these substances. So stay with me till the end of the lesson to get a good knowledge about these hydrocarbons and their derivatives. So I'll be hoping to meet you guys with our second chapter to discuss further things related to the lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.